We would like to continue our practice problems. In this particular problem, 40 rats were trained to run a maze. The following frequency histogram presents the number of trials it took each rat to learn the maze. So first let's look at this. Is this discrete or continuous data? Since we're talking about the number of trials, we can't really have between 4 and 5 trials. We have either 4 trials or we have 5 trials. So this is actually discrete data that we are looking at. And we have constructed a histogram for this data, which is right here. When you're reading this, notice it took 6 rats, 1 trial to learn the maze. It took 5 rats, 2 trials to learn the maze. It took 8 rats, 3 trials to learn the maze. It took 5 more rats, 4 trials. It took 4 rats, both 5 and 6 trials. It took 3 rats, 7 trials. It took 2 rats, 8 trials. 1 rat, 9 trials. And 2 rats, 10 trials. So I have a total of 40 different rats. What is the most frequent number of trials? Most frequent is the same thing as the mode, the one that happens the most often. And so the most frequent number of trials is 3. So the most frequent number of trials is 3. How many rats learn the maze in 3 trials or less? 3 trials or less, that signifies that we're going to take 3 trials, 2 trials, and 1 trial. So we're actually going to add up all of these. 6 plus 5 plus 8 will give me 19 rats learn the maze in 3 trials or less. How many rats took 9 trials or more to learn the maze? We're talking about 9 trials or more, so that's 9 or 10. So there are 3 rats that took 9 trials or more to learn the maze. So again, 3 rats took 9 trials or more to learn the maze. In part D, it's asking, is the histogram most accurately described as skewed to the right, skewed to the left, or approximately symmetric? Recall that the skewed direction indicates where the smaller tail is. So skewed to the right is going to look like this. It's going to have a longer tail over here. Skewed to the left is going to have a longer tail on the left-hand side. And then approximately symmetric is going to be that bell shape that we look at. So looking at these 3 possible pictures and looking at my histogram up here, if you'll notice, it kind of goes up and then goes down and has a longer tail on the right side. So this histogram is skewed to the right. So this histogram is skewed to the right. Now we want to be able to create histograms. In order to create histograms, we must first create the frequency distribution. A medical research team studied the ages of patients who had strokes caused by stress. The ages of 34 patients who suffered stress strokes were as follows. There was a patient that was 29, another patient that was 60, another patient that was 61. Remember, these are their ages. We want to construct a frequency distribution. Use 5 classes beginning with 27. So I know already that this is going to be 27 to something else. When I need to construct a frequency distribution, recall that I have to first find the class width. The class width is the largest number minus the smallest number, and then we divide by the number of classes. So our class width, we know that we're going to be dividing by 5 for this. I need to look through here and find my smallest number and my largest number. So let's start with the largest. So I have a 60, well, here's a 61. Do I have anything larger than a 61? There's a 62. Do I have anything larger than a 62? There's a 63. And nothing's larger than a 63. So 63 is my largest. Now my problem actually gives me a little bit of a hint on the smallest number, because if you notice, we begin with 27. Well, if I can find a 27 in my data, which is right here, that's going to be my smallest number. Otherwise, I would have to start at a smaller number. So 27. So I'm going to take 63 minus 27, and then I'm going to divide that by 5, and I get 7.2. Well, I don't want to really use 7.2. I tend to want to round up to the next whole number. So I'm actually going to use 8 as my class width. If you will recall, class width is the difference between the lower limit of one class and the lower limit of the next class. So if I take 27 and I add 8 to it, I get 35. The 35 actually goes in the next class. It doesn't go as my upper limit, it goes as my next class. So I've added my 8 down. I'm going to continue to add 8 down and get 43, 51, and 59. These are all my lower limits. My upper limits are just slightly under this. So if this one begins at 35, this one has ended at 34.9 to get us as accurate as possible. If this third class has begun at 43, the second class ends at 42.9. And I'm going to keep up the same pattern. Well, here I run into a little bit of a tight spot because I don't have another number here. The same way that we added 8 to each class to get the lower class limits, we can also add 8 to each of the upper limits to get the last lower limit of 66.9. So I took 58.9, I added 8, and came up with 66.9. Now we need to find the frequency for each class. So I'm going to start here at 29. It's going to go in this class, and I'm just going to do a tally mark. Honestly, the tally marks are probably the easiest whenever you have grouped data. And then the 60 I'm going to put here. Now I highly recommend that you pause the video here and you count up how many go in each class, because in just a moment I'm going to put all of those in there. So go ahead and pause the video and you find. Okay, so you should have found the following frequencies: 6, 10, 8, 5, and 5. There are 6 numbers between 27 and 34.9. There are 10 numbers between 35 and 42, or 10 patients who are between these ages. We want to find the midpoint. The midpoint, recall, is going to be the lower limit plus the next lower limit divided by 2. So I'm going to take 27 plus 35, so 27 plus 35, and divide by 2. And I get 31. I'm going to take 35 plus 43 and divide by 2 and get 39. You go ahead and pause the video and plug in the remaining midpoints. Hopefully you paused the video to see if you could calculate the midpoints. I came up with 31, 39, 41, 53, or I'm sorry, 55, and 63. That should have been 47, not a 41. There we go. In the same way that we added the class width down on the class limits, we can also add the class width down on the midpoints. Now we come over to relative frequency. Recall that relative frequency is your frequency divided by your total. I'm just going to round to 3 decimals on this. My problem doesn't tell me to, so I'm just going to arbitrarily pick 3. Okay, so I'm going to take 6 and divide by 34, because recall, n is 34. It tells us that in the actual problem itself. 6 divided by 34 is 0.176. 10 divided by 34 is going to be 0.294. 8 divided by 34, 0.235. 5 divided by 34 is 0.147. And the nice thing is I know these last two have the same relative frequency because they have the same frequency. Our last column that we're looking at in this particular frequency distribution is the cumulative frequency. Cumulative frequency means how many data values are there up to that point. So up to 34.9, there are 6 data values. Up to 42.9, there are 6 plus 10 data values for a total of 16. And then I'm going to take 16 plus 8 and get 24. I'm going to take 24 plus 5 and I get 29. 29 plus 5 is 34. This value right here, recall, should be your n, should be your total frequency there. Most of the time, the purpose of constructing this frequency distribution is so that we can make all of our graphs. Be able to visually represent this data. So the first graph that we're going to make is a histogram based on the data that we just calculated. So I'm going to go ahead and draw my vertical axes and my horizontal axes. For a histogram, recall that I'm going to use my lower class limits here on my x-axis. So my first lower limit was 27. So I'm going to put a 27. My next lower limit was 35. 43, 51, and 59. And we are discussing the ages of these people. For a histogram, most of the time we're going to use frequency. So I'm going to go ahead and label my frequency here. And my frequency goes anywhere from 5 to 10, but recall that we start at 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these dashes represents one patient. In a histogram, we're going to start out by the first one. The first class had a frequency of 6. I'm going to draw a bar. Notice I didn't put it over 27, I put it here in between 27 and 35. That's because there are 6 people between the ages of 27 and 35. Then there are 10 patients between the ages of 35 and 43. There are 8 patients between the ages of 43 and 51. There are 5 patients between the ages of 51 and 59. Notice I only used the lower limits, but I don't have something out here for my last 5 patients. the last class ends at 66.9. So what's that? What would that make the sixth class, if we had a sixth class, begin at? It would begin at 67. So I'm going to put a mark here at 67. And then that way, between the ages of 59 and 67, there were 5 patients. So recall that the histogram starts on a lower limit, ends on the next lower limit. The bars are not above that number or anything in between like that. They're in between the limits. Okay, so practice some of these and then let me know if you have any questions.